Welcome to qnawire.
Okay, let's go ahead and start this problem. So what's important to understand about this problem is the fact that sometimes there are clearly situations where Stokes' theorem is going to be a much better path than straightforwardly doing the problem itself. So as you can see, the f is quite a complex looking expression. It involves tangent inverse, first of all, and all of the inputs has all x, y's, and z's, and some of them are squared, and you have a product of them. So it's quite complex. Taking the derivative of each of those would be quite a hassle. And because of that, the curl of f looks hideous. This is the minimum amount of work that you have to be able to integrate, because remember, the curl of f is just a part of the equation of the flux integral. We also have to take a dot product of this to another vector, so it's going to be even more complicated, especially when the surface is something like this, where it's not something very simple like a plane or something. Okay, so it's clearly not a really nice problem if we try to do it straightforwardly. However, what's important to remember about Stokes' theorems is this. If I want to evaluate the integral through a surface of curl f dot ds, by Stokes' theorem, we know that it is equal to the line integral through C, which is a projection of S onto one of the planes, of f dot dr. Okay, so we just need to parameterize the curve C. So let's try to see what happens here. We have a cone, and we can project this cone onto the surface, which I like to choose the YZ plane right here. It's going to be a circle with radius 4. Okay, that's going to be my C. And when I do the parameterization, R is simply equal to the X is equal to 0. I can choose Y to be 2 cosine theta, Z to be 2 sine theta. Now this is the important part. Because we know that X is equal to 0 on the curve C, let's see what this implies in terms of F. Because X is equal to 0, this is simply equal to tangent inverse of 0, 0 squared times y, 0 squared times z squared, and then we all know that this is just simply the 0 vector. So it turns out that I don't even have to do any more calculation. The double integral ends up being 0. And that's all you need to know if you know how to use Stokes' theorem. So in summary, there are situations where the Stokes' theorem is much better an option rather than doing a surface integral straightforwardly. And that's how you solve this problem.